about that was all about the critical point. Let's now talk about the point of no return, PNR, also known as point of safe return, and we'll also talk about the concept of radius of action. So as we discussed, point of no return is the farthest point I can fly out of my departure airfield and return back to my departure airfield within the safe endurance of my aircraft. You may ask, what is safe endurance? So safe endurance is the maximum time I can fly my aircraft without using the reserve fuel. What is reserve fuel? Reserve fuel is the extra fuel which I have to carry to cater for unforeseen situations. These situations may be like in case of a diversion, or maybe some delay due to traffic or due to weather. There is also some amount of extra fuel which is carried by the pilots in an aircraft, and this extra fuel is governed by state regulations. So different countries may have different regulations about these. So what you need to know is that safe endurance is the total fuel on board subtracted by the reserves divided by the fuel consumption. So fuel on board minus reserves by fuel consumption will give you the safe endurance of your aircraft. Safe endurance will be the amount you can fly without using the reserve fuel. That's why we have subtracted the reserves from this. You'll be comfortable with this formula once we start with the numericals. So let's now look at how to calculate the point of no return. So again, I'll be making a diagram, and I want you to keep this diagram in mind whenever you're solving the questions for PNR. So again, we're going from A to B. We consider that our PNR is over here. So this is my PNR. The total time I have to be airborne is E, which is my safe endurance. Because when talking about PNR, we always consider about the safe endurance. So from A to B, I am going out on a ground speed O, which is my ground speed out. And in case I have to turn back from PNR, I will come back at a ground speed H, which is my ground speed home. Let's say the time it took me from A to PNR is T. Okay, so I took T minutes or T hours to go from A to PNR. So obviously from PNR to A, the time I would have taken would be E minus T. Right? Because total time was E. So to derive the formula for PNR, what we need to consider is something very obvious. It says that the distance A to PNR is equal to the distance PNR to A, which is very, very obvious. So if I'm going from A to PNR, let's say the distance is D. From PNR to A also the distance will be D, right? There is no doubt on it. So that is the fact we are using, that the distance out to PNR is equal to the distance home from PNR. And we know that distance is equal to time into speed, right? So the distance to PNR will be T into O, right? Which is my ground speed O. And this will be equal to the distance from PNR. Distance from PNR will be E minus T into H. Now simplifying this, I get TO is equal to EH minus TH. Therefore, T is equal to EH upon O plus H. So I come to a formula which gives me the time to PNR. So the time I will take from A to reach PNR will be EH upon O plus H. Now similarly, if I want to find the distance to PNR using the basic speed distance time formula, I will multiply the time to PNR into speed, and this speed will be my ground speed out. So time to PNR into speed will give me EOH upon O plus H. This is nothing but the distance to PNR. So the formula for distance to PNR is EOH upon O plus H, and the formula for time to PNR is EH upon O plus H. Now something very important which you need to know is that this E is always in hours. Okay, so whenever you're using this formula, make sure E is in hours. Perfect. Okay, so let's now talk about another application of the PNR concept, and it is the calculation of radius of action. Now, to make you understand radius of action, let me take an example. Let's say I am a search and rescue pilot and I have to carry a search and rescue operation. I have 2000 pounds of fuel on board. The reserve fuel out of that is 500 pounds and my aircraft's fuel consumption is 500 pounds per hour. So to calculate the maximum distance I can go out, carry out a search and come back safely within my safe endurance, I will have to find the radius of action. And to find the radius of action, I will have to use the PNR concept. So let's see how. So I told you that the total fuel on board I have is 2000 pounds, out of which 500 pounds I am carrying reserve fuel. And my fuel consumption is 500 pounds per hour. So let's find the safe endurance first. Safe endurance, I told you, was fuel on board minus reserves upon fuel consumption. So fuel on board minus reserves will be 2000 minus 500, which will give me 1500 pounds divided by 500 pounds per hour. So every hour I'm consuming 500 pounds. In how much time will I consume 1500 pounds? 3 hours. So my safe endurance comes out to be 3 hours. So E is 3 hours. Now how do I find my radius of action? To find my radius of action, I need a couple of things, which is my ground speed. So let's say my ground speed out is 200 knots and ground speed back home is 180 knots. It is different due to winds. Now to find the radius of action, all I'll find is the distance to PNR. Why? Because distance to PNR is the maximum distance I can go and come back within the safe endurance of 3 hours in this case. I will use the formula distance to PNR is equal to EOH upon O plus H. E is 3, 200, 180 upon 200 plus 180. It is 284 nautical miles. So if I'm carrying out a search, let's say I'm over here, the maximum distance I can go out is 284 nautical miles, after which I will have to turn back and come back to my departure airfield. Similarly, if I go out in this direction, I will go for 284 nautical miles before I turn back. So I can go in any direction, but maximum I can go out is 284 nautical miles before I have to come back to my base. Okay, so this is nothing, just the radius of action. So this is the radius in which I will do all the action. Perfect. So that was the concept of radius of action. Let's now look at some numericals for better understanding. So the first one, with a fuel of 10,000 pounds, PNR is calculated to be 880 nautical miles. Other factors being constant, if fuel is increased to 11,000 pounds, the distance to PNR will be. Okay. So to solve this question, first I will just write the distance to PNR formula. So distance to PNR is equal to EOH upon O plus H. Now you'd be wondering, I don't have enough information to solve this. But I have written the formula only for one thing. For you to realize that distance to PNR is directly related to my endurance, right? And endurance is directly proportional to the fuel I am carrying, to my fuel on board. Now, if my fuel on board increases by a certain percentage, my endurance will increase by the same percent. And that in turn will increase my distance to PNR by the same percentage. So for example, my fuel on board increased by 1%. My endurance will also increase by 1%. And in turn, my distance to PNR increases by 1%. So this is a fact which you need to know. Now to solve this question, I will just find out the percentage increase in my fuel. So earlier I had 10,000 pounds of fuel. I'll write old fuel on board. Now I have 11,000 pounds of fuel, which is my new fuel on board. The old distance to PNR I was given was 880 nautical miles. And I need to find the new distance to PNR. So just by ratio and proportion, old fuel on board divided by new fuel on board is equal to old PNR by new PNR, let's say X. So my new PNR comes out to be 968 nautical miles. As simple. Another way to solve this question, I see that my fuel on board has increased by 10%. So since my fuel on board increased by 10%, my distance to PNR will also increase by 10%. What is 10% of 880? 10% of 880 is 88. When I add 88 to 880, I get 968 nautical miles. So the percentage increase in my fuel is equal to the percentage increase in my distance to PNR. That's it. Okay, so let's look at the next example. In this we are given the total endurance, the reserve fuel and the ground speeds. What we need to find is the time and distance to PNR or PSR from the departure airfield. So before I do anything, first I will draw the diagram for PNR. So A to B, and considering my PNR to be, let's say, over here. So in this diagram, we know that from A, I am going out on a ground speed O, which is my ground speed out, and from PNR, I am coming back with ground speed home. If you saw the diagram I made for PNR, you would have noted that there is no ground speed on in this diagram. So this information is just extra, just to confuse you. So just using the time and distance to PNR formulas, I'll get the answer. So for the formulas, we need safe endurance. What is safe endurance? Just my total endurance minus the reserve fuel, which is 4 hours. Here I did not divide it by fuel consumption because I already have it in hours. So total endurance was 5 hours. I just subtracted the reserve endurance, which was 1 hour. Now I'll just put it in the formulas to get the time and distance to PNR. So time to PNR, EH upon O plus H. So the answer I get will be 2 hours 8 minutes. So this is the time to PNR. Talking about the distance to PNR, I will use the formula EOH upon O plus H. So I'll just multiply this 2 hours 8 minutes with my ground speed out, which is of 280 knots. And the answer I will get is 597 nautical miles. So the distance to PNR from departure is 597 nautical miles and the time to PNR will be 2 hours and 8 minutes. Awesome, let's look at the next question. So in this question, I am given course and wind velocity. So as we did for CP, I will use my flight computer for finding the ground speeds. Before that, let me draw the diagram. So we are going from A to B. The course is 030 degrees. That's why I have drawn it like this. Let's say PNR is over here. So I will need 2 ground speeds. One will be out and one will be home. That is all I would require. The safe endurance I am given 3 hours 20 minutes. The winds that I have given in the question are from 100 degrees at 30 knots. So this is the wind that I am getting. So in the question, if you see, I have both my total endurance and safe endurance. But as you all know, we will only look at the safe endurance. And another extra information which I have in this question is the distance A to B. In PNR, we do not require the distance A to B. We need that for CP. So all this is just to confuse you, but if your concepts are clear, you won't get confused. So using the TAS, track and wind velocity, let's find our ground speed out and ground speed home. So for ground speed out, I'll take my CX3, put in the TAS of 160 knots, track of 030 because I'm going A to B and track 030 is given, wind speed 30 knots, wind direction 100. The ground speed I get is 147 knots. Talking about my home ground speed, so for home ground speed I will have to take the reciprocal of 030. So reciprocal of 030 will be 210 degrees. So again on my CX3 I will take TAS 160. Track this time will be 210 degrees. Wind speed 30 knots, wind direction 100. So the ground speed that I get is 168 knots. So I have all the information. Let's put it to the formulas. So time to PNR EH upon O plus H. I first convert my time to hours. So to convert this to hours, I will divide 20 by 60. So I get 0.333. So my safe endurance will be 3.33 hours. If you're using a scientific calculator, you can put this value directly as well using the degrees, minutes and seconds function. But if you don't have a scientific calculator, you just convert the 3 hours 20 minutes to hours and you'll get 3.33. So putting it in the formula, I take 3.3 into H of 168 divided by 147 plus 168. So the time to PNR I get is 1 hour 45 minutes. Now what is the distance to PNR? To find the distance to PNR, I will use the DPNR formula. E was 3.3, O 147, 168 upon 147 plus 168. So this distance I get is 261 nautical miles. Now there is another part to this question in which I am given that we depart A at 0930 hours UTC. So what time will we reach our PNR? So this is a very easy part. We know that the time to PNR is 1 hour 45 minutes. So if I take off at 0930 hours, I will reach PNR at 0145 hours. So adding both the time, I get 1115 hours. So I will reach at 11:15 hours. So that is all for this question. Now another type of question, or in fact another formula which we need to talk about in PNR is if our fuel consumption was not constant. So in the previous examples, what we assumed was that the fuel consumption throughout the sortie or throughout the flight was constant. From A to PNR, from PNR to A, the fuel consumption was always the same. So if my fuel consumption was 500 pounds per hour, it was always 500 pounds per hour throughout the sortie. But what will happen if my fuel consumption from A to PNR is different to what it is from PNR to A? What if I was going out and my fuel consumption was 500 pounds per hour, but when I'm coming back, the fuel consumption increased to 700 pounds per hour? What will I do in this case? So for this kind of situation, I will use this formula. So distance to PNR is equal to my fuel on board minus reserves divided by fuel consumption out plus fuel consumption home. So fuel consumption out means the fuel consumption when I was going out to the PNR. Fuel consumption home means the fuel consumption when I was coming home from the PNR. And both of these fuel consumptions have to be in kg per nautical mile. So how much fuel I am consuming per nautical mile is what I care about. Alright, simplifying this formula, I can write that my distance to PNR is fuel on board minus reserves divided by my fuel consumption out upon my ground speed out plus fuel consumption home upon ground speed home. So this is the formula which I need to know if I want to find my distance to PNR with variable fuel consumptions and variable ground speeds. Since I wanted my fuel consumption in kg per nautical miles, I've just simplified it. So now it is fuel consumption upon ground speed. Fuel consumption is in kg per hour, ground speed is knots, which is nautical miles per hour. So I'll just write the units over here. Fuel on board is in kg, the reserves are also in kg. Fuel consumption kg per hour, ground speed nautical mile per hour. Same for fuel consumption home and ground speed home. So here if you see, your RR will get cancelled and you will get kg per nautical mile, and that is what we wanted over here, kg per nautical mile. So I'm just helping you out with elaborating the formula. Let's look at a couple of examples for better understanding of this formula as well. So here this one. What is the distance and time to PSR from A? Ground speed out, fuel flow out. Ground speed home, fuel flow home. Total endurance, reserves required. So I'll just write the formula down. Formula was distance to PNR is equal to now I don't have to do anything. I just have to substitute the values to this formula. So the distance to PNR becomes 15,000 kg minus reserves 3,000 kg divided by 2800 kg per hour. Ground speed out I am given 400 plus fuel flow home 2500 kg per hour and the ground speed home is 450 nautical miles. So you just solve this and you get the distance to PNR as 955 nautical miles. So now we have the distance to PNR. Let's find the time to PNR. The basic speed, distance, time formula, we know that time is equal to distance upon speed. So distance is 955 and speed out. So if I draw the diagram for reference, PNR is over here, which is at 955 nautical miles. This is my ground speed out. From here I need ground speed home. And ground speed out I am given as 400 knots. So 955 upon 400, I solve it and time I get it as 2 hours 23 minutes. So the distance to PNR is 955 nautical miles. The time it will take me to reach to the PNR will be 2 hours and 23 minutes. Perfect. Let's look at the last example. What is the distance and time to PSR from P? Total fuel 16,000 kg, reserves 1500 kg. P to Q distance 2050, fuel required 11,500. Q to P distance 2050, fuel required 10,200 kg. Okay, let me draw the diagram. This is P, this is Q. 2050 nautical miles. Let's say PNR is over here. I'm going out home, though this is not important, but just for reference. Okay, so let's find the safe endurance first. So safe endurance will be total fuel minus reserves. So that will be 14500 kg. Perfect. Now distance to PNR is equal to, and both of these values are in kgs per nautical mile. 16,000 minus 1500 kg divided by. Now to find my fuel consumption out, I will use my fuel divided by the distance. That is how I will get my kg per nautical mile. Fuel is in kg, distance is in nautical mile. So first I am going from P to Q. Distance 2050, fuel required 11,500. So fuel consumption out is 11,500 divided by 2050 kg nautical mile, giving me an answer in kg per nautical mile. Similarly, for fuel consumption home, I will use 10200 kg, which is my fuel required from Q to P, and Q to P distance is also 2050 nautical miles. Again, this is in nautical miles and this is in kg. By solving this, the answer I get is 1369 nautical miles. So my PNR is located at a distance of 1369 nautical miles from P. And that is how I solved this question. The main thing to note here was that the units are in kg per nautical mile. So whatever information you are given in the question, use it in such a way to make this unit of kg per nautical mile in the formula. Okay, so before I end this video, let me talk about some important derivations or important exam questions you can get from PNR. So the first one says that the distance to PNR is maximum in nil winds. So if there is a nil wind condition, then only the distance to PNR will be maximum. Any other wind except for this, the distance to PNR will always decrease. You can take endless examples to prove this fact. First find the PNR in nil winds and then take any wind component and find the PNR. The second PNR will always come out to be lesser than the first one because in nil winds it is maximum. Next, what happens in beam winds? So whenever there are beam winds, the distance to PNR will reduce. Why? Because any wind component, the distance to PNR always reduces. What happens to the time to PNR? So the time to PNR in this case remains the same. Alright. So you should know what happens in beam winds with respect to the position of CP and also to the PNR. Now, one more important thing to note is that the distance to PNR is directly proportional to the fuel on board. So, the more fuel you have, the further will be the PNR. Because when you increase the fuel on board, your safe endurance will increase. How will the safe endurance increase? Because the total endurance increases. If I was carrying 1000 pounds of fuel, I was flying for 2 hours. Now, if I'm carrying 3000 pounds of fuel, obviously I'll fly more than 2 hours, right? It will be 3 times. So, if your fuel on board increases, your endurance increases, and as the endurance increases, the distance to PNR increases, and vice versa. If the fuel on board decreases, the distance to PNR will decrease. Also, if I talk about fuel consumption, so the distance to PNR is inversely related to the fuel consumption. If my fuel consumption increases, that means my aircraft is consuming more fuel. So what will happen? My endurance will reduce. In 1000 pounds, if my fuel consumption was 500 pounds per hour, I was flying for 2 hours. Now, if my fuel consumption is 1000 pounds per hour, I'm only flying for 1 hour. So my endurance is decreasing, and as the endurance decreases, the distance to PNR also decreases. Similarly, if your fuel consumption decreases, meaning that now your engine is more efficient, so the endurance will increase, the ability of the aircraft to remain in the air increases, and the distance to PNR will automatically increase. Okay, so these are some important facts about point of no return, which are very common questions in the DGCA or any other exam.
Okay, so that was all about CP and PNR. I hope you understood the topic well, because as I told you earlier, it is not only important for the exam point of view, but also very important for day-to-day flying purposes. So if you have any doubts, just put it in the comment section. Also, do let me know in the comment section about the next topic you want me to cover from navigation. Okay, so I'll see you next time. Thanks for watching.